1800 there were now hundreds, and already chemistry, which had been content with her atoms and molecules for the better part of a century, was preparing herself for that vast next stride that was to revolutionize the whole life of man from top to bottom. One realizes how crude was the science of that time when one considers the case of the composition of air. This was determined by that strange genius and recluse, that man of mystery, that disemboweled intelligence, Henry Cavendish, towards the end of the 18th century. So far as he was concerned the work was admirably done. He separated all the known ingredients of the air with precision altogether remarkable. He even put it upon record that he had some doubt about the purity of the nitrogen. For more than 100 years his determination was repeated by chemists all the world over. His apparatus was treasured in London. He became, as they used to say, classic, and always, at every one of the innumerable repetitions of his experiment, that sly element argon was hiding among the nitrogen, and with a little helium and traces of other substances, and indeed all the hints that might have led to the new departures of the 20th century chemistry. And every time it slipped unobserved through the professional fingers that repeated his procedure. Is it any wonder then, with this margin of inaccuracy, that up to the very dawn of the 20th century scientific discovery was still rather a procession of happy accidents than an orderly conquest of nature? Yet the spirit of seeking was spreading steadily through the world. Even the schoolmaster could not check it. For the mere handful who grew up to feel wonder and curiosity about the secrets of nature in the 19th century, there were now, at the beginning of the 20th, myriads escaping from the limitations of intellectual routine and the habitual life in Europe, in America, North and South, in Japan, in China, and all about the world. It was in 1910 that the parents of young Holston, who was to be called by a whole generation of scientific men the greatest of European chemists, were staying in a villa near Santo Domenico, between Fiesole and Florence. He was only then 15, but he was already distinguished as a mathematician and possessed by a savage appetite to understand. He had been particularly attracted by the mystery of phosphorescence and its apparent unrelatedness to every other source of light. He was to tell afterwards in his reminiscences how he watched the fireflies drifting and glowing among the dark trees in the garden of the villa under the warm blue night sky of Italy, how he caught and kept them in cages, dissected them, first studying the general anatomy of insects very elaborately, and how he began to experiment with the effect of various gases and varying temperatures upon their light. Then the chance present of a little scientific toy invented by Sir William Crookes, a toy called the spinthariscope, on which radium particles impinge upon sulphide of zinc and make it luminous, induced him to associate the two sets of phenomena. It was a happy association for his inquiries. It was a rare and fortunate thing, too, that any one with the mathematical gift should have been taken by these curiosities. Section 8. And while the boy Holston was mooning over his fireflies at Fiesole, a certain professor of physics named Rufus was giving a course of afternoon lectures upon radium and radioactivity in Edinburgh. They were lectures that had attracted a very considerable amount of attention. He gave them in a small lecture theatre that had become more and more congested as his course proceeded. At his concluding discussion it was crowded right up to the ceiling at the back, and there people were standing without any sense of fatigue, So fascinating did they find his suggestions. One youngster in particular, a chuckle-headed, scrub-haired lad from the Highlands, sat hugging his knee with great sand-red hands, and drinking in every word, eyes aglow, cheeks flushed, and ears burning. "And so," said the Professor, "we see that this radium, which seemed at first a fantastic exception, a mad inversion of all that was most established and fundamental in the constitution of matter, is really at one with the rest of the elements. It does noticeably and forcibly what probably all the other elements are doing with an imperceptible slowness. It is like the single voice, crying aloud that betrays the silent breathing multitude in the darkness. Radium is an element that is breaking up and flying to pieces. But perhaps all elements are doing that at less perceptible rates. Uranium certainly is. Thorium, the stuff of this incandescent gas mantle, certainly is. Actinium. I feel that we are but beginning the list. And we know now that the atom, that once we thought hard and impenetrable, and indivisible, and final, and lifeless, is really a reservoir of immense energy. That is the most wonderful thing about all this work. A little while ago, we thought of the atoms as we thought of bricks, as solid building material, as substantial matter, as unit masses of lifeless stuff, and behold! These bricks are boxes, treasure boxes, boxes full of the intensest force. This little bottle contains about a pint of uranium oxide, that is to say, about 14 ounces of the element uranium. It is worth about £1. And in this bottle, ladies and gentlemen, in the atoms in this bottle there slumbers at least as much energy as we could get by burning 160 tons of coal. If at a word, in one instant, I could suddenly release that energy here and now, it would blow us and everything about us to fragments. If I could turn it into the machinery that lights this city, it could keep Edinburgh brightly lit for a week. But at present no man knows, no man has an inkling of how this little lump of stuff can be made to hasten the release of its store. It does release it, as a burn trickles. Slowly the uranium changes into radium. The radium changes into a gas called the radium emanation, and that again to what we call radium A, and so the process goes on, giving out energy at every stage, until at last we reach the last stage of all, which is, so far as we can tell at present, lead, but we cannot hasten it. "I take ye, man," whispered the chuckle-headed lad, with his red hands tightening like a vice upon his knee. "I take ye, man. Go on, oh, go on." The Professor went on after a little pause. "Why is the change gradual?" he asked. "Why does only a minute fraction of the radium disintegrate at any particular second? Why does it dole itself out so slowly and so exactly? Why does not all the uranium change to radium, and all the radium change to the next lowest thing at once? Why this decay by driblets? Why not a decay en masse? Suppose presently we find it is possible to quicken that decay." The chuckle-headed lad nodded rapidly. The wonderful inevitable idea was coming. He drew his knee up towards his chin and swayed in his seat with excitement. "Why not?" he echoed. "Why not?" The Professor lifted his forefinger. "Given that knowledge," he said, "mark what we should be able to do. We should not only be able to use this uranium and thorium, not only should we have a source of power so potent that a man might carry in his hand the energy to light a city for a year, fight a fleet of battleships, or drive one of our giant liners across the Atlantic,